Today we're going to do lesson 7, which is more zero product law. So you got a lot of practice yesterday doing more zeros of quadratics. Hopefully that was able to strengthen the skill for you. And now today we're going to just take it a little bit further. So the zero product law's importance to mathematics cannot be overstated. It finally allows us in certain situations to solve equations that are higher order polynomials than just linear. Of course, for it to work, we have to have two conditions met. The first thing is that the equation has to be set equal to 0. So we can't use the zero product law to solve a quadratic equation unless the equation is set equal to 0. Okay? The second requirement or condition is that we have to be able to factor the expression equal to 0. So if we can't factor it, then it's not going to do us any good. Okay? So to start out, we're going to solve each of these using factoring. So for exercise 1a, we're going to factor x squared plus 2x minus 35 equals 0. So this one is a simple one. We can think of, I have my first leading coefficient is 1, so I know I'm going to be able to hopefully double bubble this. All right, and it's equal to 0. I'm thinking of the I'm thinking of the two numbers that are going to multiply together to give me negative 35, but will also add up to 2. So you should be thinking probably 7 and 5. And remember that if the last term is negative, that means that the two numbers are different signs, and the middle term will tell you which one is larger. So the negative 35 means that we have two different signs. So our 7 and our 5 are going to be, one is going to be positive, one's going to be negative, and the middle term being positive tells you that it's the larger one. So the larger would be 7, so this is going to be plus 7 and minus 35. I'm sorry, minus 5. And if you need more clarification on that, remember, 7 times negative 5 gives me negative 35. 7 plus negative 5 gives me 2, which is what we want. Okay, so remember what we do here is we split it up. We set each piece equal to 0, and we solve. On this side, x is equal to negative 7. And on this side, x is equal to 5. So my two zeros of this function would be negative 7 and 5. And writing it as a solution set, which I've been doing, you would put the smaller one first, negative 7, comma 5. Okay? And we have the slightly more complicated ones. What we always want to try to do, like I've told you guys many a time, is always try to factor out a GCF first. So looking at this, you might be thinking that you have to do grouping, but please always check if you have a leading coefficient that's greater than 1, make sure that you can't factor it out first. In this case, I'm going to be able to factor out a 3 from all of these numbers. So if I take a GCF of 3 out, I'm left with x squared minus 10x plus 16 is equal to 0. And now this I can easily factor instead of having to go through the whole process of grouping, which would not go well for you. So this is going to, you just always have to remember to keep that number outside, right? We're going to double bubble. Remember to keep the equal to 0 at the end. And we're thinking what two numbers will multiply together to give me 16, but also add up to give me negative 10. Remember that the last term being positive means that they're both the same sign, and the middle term will tell you what that sign is. So it's negative, so they're both going to be negative, right? To get a positive answer when you're multiplying negatives, they both have to be negative, right? So this is going to be 8 and 2. Negative 8 times negative 2 gives me positive 16, and negative 8 plus negative 2 gives me negative 10. Okay, so now I'm fully factored, and I'm going to split this up and set them both equal to 0. Remember that if you have a coefficient outside like this, it does not change anything about your answer. You can actually just get rid of it, because what it's really saying is that 3 equals to 0, right? And that's not the case. So we're really just going to ignore the 3, and we're going to keep x minus 8 equals 0 and x minus 2 equals 0. Just to clarify, the reason why is because this is technically its own section. 3 equals 0 is not true, so we're going to just ignore that. Okay? Now we solve. Here is x equals 8, and I add 2 to both sides here, and x equals 2. So my final solution set, the smaller one comes first, 2, 8. Okay? Now, let's take a look at this guy here. Believe it or not, this can actually be factored. And in order to factor this, we have to call upon one of these skills that we learned way back when we were still in school, where you can factor out a common binomial. So separated by the plus sign, we have 2 separate terms here. What they both have in common is this binomial of x minus 3. And we did a lot of practice with this, so I'm hoping that you guys are comfortable. But remember, you take it out like this and bring it to the front. And then whatever's left, you add together. So I have my x minus 3 factored out. That leaves me with x plus 1 plus, and remember, if this had been a minus, we would have changed the signs of both of these, 2x minus 7 equal to 0. And then once we combine these, we're going to already have our 2 binomials. We won't even have to factor anything else. So this is going to be x plus 2x, which is 3x, plus 1 minus 7, which is negative 6, equals 0. And then we just set each of these equal to 0 to solve. So I have x minus 3 equals 0, and I have 3x minus 6 equals 0. So solving here, add 3 to both sides. X is equal to 3, that's my first 0. And then here, add 6 to both sides. I have 3x equals 6, sorry, I'm running out of room. Divide by 3, and x is equal to 2. So my 2 zeros are 2 and 3. So as a solution set, smaller one comes first, 2, 3. Okay, so this is basically just more or less a wrap up with the simplest type of a problem here, a medium problem here, and a somewhat tricky one here. And yesterday what you saw was situations where you can actually solve the equation, but you have to use more complicated factoring such as grouping. So for exercise 2, what we're going to do is we're going to remember why it's such a crucial skill with parabolas. So James graphed the quadratic y equals 3x squared plus x minus 10 using the tables on his calculator, and he found this graph. He can tell from his graph and the table that x equals negative 2 is one of the 2 zeros, but he wasn't able to tell what the other one was because it wasn't on an integer. So what that means is he tried to trace it on his calculator. Remember when we did second trace, when we did our systems of equations, you can look at a graph and try to trace where that 0 is too. However, it's not always directly on an integer. So right here, this point, it's in between, as you can see, 1 and 2. So he couldn't tell exactly what that 0 was. Now that we have these skills of using the zero product law to solve, you can find the exact 0 where you can't do that in the calculator. So what we're going to do first is we're going to write an equation that's going to allow us to solve for the zeros. So all that means is take your quadratic equation, and in order to find a 0, you have to set it equal to 0. If it's not equal to 0, you can't do that. So all we're going to do is we're going to take our quadratic, 3x squared plus x minus 10, and we're going to just set it equal to 0. That's it. For part B, they're asking us, how does knowing that x equals negative 2 is a 0 already help us to factor the trinomial? Well, if we know that x is equal to negative 2, then that probably means that one of the bubbles, when we factor it, is probably x plus 2, right? Because if we solve for x plus 2, we would get x equals negative 2. So while you would normally be using grouping here, you can try to figure this out and see what times x is going to give me 3x squared. So you know it's got to be 3x. And now you're going to think to yourself, I'm going to have this 6x, oh my gosh, sorry, and then adding something to that should give me x. So it's going to have to be negative 5. And if you weren't able to figure it out from there, you know that you have to have negative 10. So 2 times what would give you negative 10. So that's just one way of doing it. But you absolutely could have used grouping and done that over here. This is one that you could actually do in your head knowing that the 0 was negative 2. Okay, if that didn't make sense to you, you just factor like always, okay? So now they're telling us to factor it. Now in step C, we're going to actually solve it. So we already know this 0, okay, but I'm still gonna write it. And we're gonna solve. So we already knew x plus 2. We already knew that the first 0 was negative 2, okay, that was a given. So now we're gonna find the other 0. So we have 3x minus 5 equals 0. I add 5 to both sides. I get 3x equals 5, and then divide by 3 on both sides. So the 0 that James was looking for, that he could not identify in his graph, is 5/3. And that's it. And of course, if you really wanted to write that as a mixed number, it would be 1 2/3. And you don't have to write that. I'm including it just in case, as I know sometimes you guys do that. Okay, so let's go to the next page. So now that you have the skills to factor, one of the really cool applications is that we can explore higher order polynomials and their zeros. Now, as Kirk is saying, it's a very limited basis that we can do this on, but you know, we can actually analyze some of them. So far the best that we've done is an x squared, but polynomials that contain an x cubed can also be analyzed, and we call them cubics. Okay, kind of makes sense, right? They're cubed. So let's say we look at the cubic function f of x equals x cubed minus 9x. In this case, we can actually find all of the zeros by factoring. So if we take a look here, if we want to find the zeros, we have to set it equal to 0, right? So we have x cubed minus 9x, and let's set it equal to 0. And now let's factor. So we want to look for a GCF, right? First things first. I can take an x out of both of these, right? So if I factor out an x, what I have left is x squared, minus 9 equals 0. And now hopefully this is screaming dots to you. This is difference of two perfect squares, right? So you can further factor it, keeping that x outside. So this would be x plus 3, x minus 3 equals 0. And remember the difference of two perfect squares, that's the square root of the first and the square root of the second. One is a plus, one is a minus. Now this is factored completely. So I'm going to break it up, and I'm going to solve each one and set it equal to 0. So this x counts because it's a variable. I'm going to set all three of them equal to 0. So the first 0, x equals 0, that's just it. That's the solution. Now x plus 3 equals 0. Subtract 3 from both sides. X is equal to negative 3. That's my second 0. And then finally, my x minus 3 equals 0. Add 3 to both sides. And my third 0 is x equals 3. So as a final solution set, smallest one would be negative 3, then 0, then 3. Okay, so this would be all of the zeros of this function. Okay, now I have to grab my calculator, but you're going to enter this function right here into y equals, and you're going to sketch what it looks like, and you'll be able to see that these zeros really do correspond to where they are on your calculator. So let me just go grab my calculator real fast. Okay guys, sorry about that. So I'm going to plug this in, x cubed minus 9x in here. Okay, so x cubed, you can use the caret 3 minus, or was it plus? Minus 9x. Okay, and I'm going to look at the graph. And as you can see, a cubic function looks something like this. Okay, and they're just asking you to sketch. And now we know what our zeros are. We already knew them. It was 0 here, negative 3 here, and positive 3 here. So these are my 3 zeros, and it is solidified by looking at this graph, right? I should add my little arrows here. Okay. So when you get to Algebra 2, you're going to be studying higher order polynomial functions. But you should be able to find zeros for a limited number of cubic polynomials that can be easily factored. So that was a really super simple one to factor, and there are others like that. So when you have a situation like that, you should be able to do it. So in our last exercise, we'd like to explore the relationship between the zeros of a quadratic and the x-coordinate of its turning point. So we're going to start off by looking at the quadratic y equals x squared minus 8x plus 15. So first thing we're going to do is we're going to find the zeros. So this is a leading coefficient of 1, so we should be able to double bubble this easily. First thing I'm going to do, since I'm finding zeros, is I'm going to set this equal to 0. 8x squared minus 8x plus 15 equals 0. Double bubble. Okay, I have an x and an x. My last term is positive. My middle term is negative. So that means they're both negatives. So what two numbers multiply together to 15 and add up to 8? Or in this case, negative 8. This is going to be 5 and 3. Negative 5 and negative 3. Negative 5 times negative 3 is 15. Negative 5 plus negative 3 is negative 8. Okay, so now let's find the zeros. Separate it. X minus 5 equals 0. And x minus 3 equals 0. Add 5 on both sides. My first zero is x equals 5. Add 3 on both sides. My second zero is x equals 3. So, as a solution set, that's 3 comma 5. Okay, so now I know my two zeros. B. Now what I want to do is I want to write my quadratic function in vertex form. And I want to identify the coordinates of its turning point. So remember, to write something in vertex form, we were using completing the square, right? So first I'm going to keep the y equals here. X squared minus 8x plus 15. To complete the square, we take our middle term. That's negative 8. Divide it by 2, negative 4, and square that, which is 16. And remember, we're adding and subtracting that. So, we have y equals x squared minus 8x. So I'm going to add my 16 in here. And then I'm going to subtract my 16 and keep my plus 15 here, right? And remember that this is getting broken up here, kind of like this. So the point is that this should be a perfect square trinomial, right? And that means you go back to this term that you squared before, and that's going to be the number inside your parentheses. So this is x minus 4 squared, right? And now negative 16 plus 15 is negative 1. So here is my quadratic function in vertex form. And now I can tell you what the turning point is, right? It's the opposite of what's in here. So that's going to be 4. And it's the same as this last number. So negative 1. That's my turning point. Okay? Now what? C. What is true about the x-coordinate of the turning point compared to the zeros you found in part A? So if you look at the x-coordinate in the turning point the x-coordinate in the turning point compared to these two zeros, what do you notice about that number? It's not that it's the same, but what about the location of that number? So 4 is in between 3 and 5, right? So we want to know if that is always the case. So what we notice here is that the x-coordinate, I'm going to abbreviate, of the turning point is halfway between the two zeros. Okay? Another way of saying that is it's the average. The average of the zeros. Right? Now, without using a calculator, we want to sketch a graph of the quadratic on the axes below. So the idea is we should be able to make a sketch of this using the zeros and the turning point. So if I know the zeros, I know that's where they cross the x-axis, right? So 3 and 5. So 3, 4, 5. My turning point is 4, -1. So here's 4, and here's -1, right? Those are the only 3 points I need to draw a rough sketch, right? So here we go. Whoop, just like that. So the idea is, if you think about it, you have your 2 zeros. Your turning point really should be, the x-coordinate should be halfway between there, because that's where it starts to mirror itself on the other side, right? Okay, so let's finish this up with exercise 5. A quadratic function can be written in factored form as y equals x plus 3, x minus 7. Which of the following would be the coordinate of its turning point? So what we're doing is we're using what we just discovered here to actually find the x-coordinate of the turning point. So what we noticed was that the x-coordinate was halfway between the 2 zeros. In other words, it was the average. So what we're going to do is we're going to just find our 2 zeros. So I'm going to take my x plus 3, x minus 7, set it equal to 0. Find the 2 zeros. This is x plus 3 equals 0, x minus 7 equals 0. So the first 0 is -3. The second is 7. Now you can sit here and figure out which one is halfway between them, or you can just quickly find the average, which, remember, to find the average, we add them up. So -3 plus 7, and we divide by 2. So this is 4 divided by 2, which is 2. So my x-coordinate is halfway between -3 and 7, which ends up being at 2. So that's x equals 2. Okay, guys? So that's it for the more zero product law lesson. And you're going to get, what is it? Tomorrow we're going to do another lesson that's not in the book, so make sure you print it out before you start the video. Okay, have fun.